So friends, let us move on to the next problem. A spring balance has a scale that reads from 0 to 50 kg. The length of scale is 20 centimeter. A body suspended from this balance when displaced and released oscillates with a period of 0.6 seconds. What is the weight of the body? Okay. So now here you have been given the time period. Okay, I'll just write it here. T is equal to 0.6 second. Okay. This scale, it reads from 0 to 50 kg and the length of scale is 20 centimeter. So what does it mean? So that means when I suspend a mass of 50 kg, the spring will expand or elongate to how much? It would be 20 centimeter. Correct. When nothing is when the mass is 0, the spring, the pointer will point at 0 kg, and when I suspend 50 kg from this balance, from the hook, okay, it will it will extend by 20 centimeter. Okay, so that is what is known here. So what is the use of that? The use of that is you can get the spring constant. Okay, now what about the time period? Time period of SHM, or time period of oscillations, that is 0.6 seconds. But then my T, is it not 2 pi upon omega, right? So what about omega here? Okay, we knew that omega square is equal to k upon m, right? So what is my omega? So my omega would be equal to square root of k upon m. Correct. That means my T is going to be equal to 2 pi root over m upon k. I am just taking reciprocal of this, okay, and just multiplying it by that to 2 pi to get the time period. Okay, so but then this mass, okay, this m here, okay, this m is not equal to this, so I'll call this as m1. Okay, because this m1, that is going to be useful for finding the value of k here. Okay, so let us do that. F is equal to minus kx, but then I'll write kx. F is equal to kx, and that f, that is equal to m1g, is going to be equal to k into x. So that x I'll take on this side. Okay, so therefore my k is equal to 50 into 9.81 divided by 20 centimeter, that would be 0.2 meter. So that would be equal to 0.2. So 50 upon 0.2, it is going to be equal to how much? 250, correct, into 9.81. So that many newtons per meter. Okay, now let us substitute that k over here. Okay, so this T will be equal to 2 pi root over, now this is okay, but then now here we will just change it. We won't substitute that value of k over there because m is not known, T is known. Okay, T is known, I want to find out m, correct? So instead of doing this, I'll change this and I'll first of all derive the formula, simplify the formula for m. So for that, what I do is I square here, T square is equal to 4 pi square into m upon k, correct? So my m would be equal to k T square over 4 pi square, right? So this would be equal to, what is your k? It is 250 into 9.81 multiplied by t, time period is 0.6 seconds, so 0.6 square, and then that divided by 4 into pi square. So that I am keeping as it is. Now here you must have noticed that I have not calculated 250 into 9.81 because I don't think it is necessary. In the problem, have they asked you what is the spring constant over there? No. So there is no point in wasting my energy over here. So I will not calculate that, right? And then after I substitute here, so I'll substitute it like that, right? 250 into 9.81, nothing wrong in that. And then I'll be doing the calculations only once. Okay, so now with your calculator you can find this the value of this mass, and it will be so many kilograms. Okay, so the mass to be suspended from the spring balance, okay, which when slightly pulled and released will perform simple harmonic motion, or it will oscillate with a period of 0.6 seconds, right? In the next video we are going to do a few more problems. Thank you so much.